Very well. I will start this presentation in a second. We are going to review one of the use cases of the primary use cases for the CloudEHRServer. So I will just open a couple of windows more here. The use case that we are going to review today, this is the first video of the first presentation of a series. The idea is to review in a small video or small as possible each of the possible use cases for the EHRServer. Today I will talk about how we do clinical decision support with the EHRServer, based on the EHRServer, with the use of it. And if you're watching this through YouTube, you will find a small live chat there where you can ask questions, and I will try to answer you. I'm trying to find where I can see the chat. Let's see if I can access the chat from here. Okay, I can see the chat now. So very basic. I will start with the presentation. So my name is Pablo Pasos. I'm the director of CaboLabs, Health Informatics. We designed and developed the EHRServer. The EHRServer is a generic clinical data repository based on the OpenEHR standard, and has a REST API where you can just use for storing your data and querying your data. So you can really access your information in several ways using the same consistent API, and is compliant with the OpenEHR standard. You have more information about the project. The project is open source. You can find more information here. If you come to CaboLabs, you're an English speaker, you click just on English and you go to the project page. You can find some information, features, etc. And you have a demo here of the latest version of the EHRServer, and also some documentation and the technical guide. This is a complete guide where you have all the information, all the specification of the API of the EHRServer. So that is technical. So here is all the information. And the CloudEHRServer, what it is a software as a service that is based on the EHRServer project. So it's based on an open source software. So it's the same tool, but you don't need to manage the infrastructure. So it's basically it. And we are going to use the EHRServer, the CloudEHRServer, as a base for our clinical decision support processes. Yeah. So what is clinical decision support in a nutshell? So very brief. Basically, are all the processes, all the tools, all the techniques, all the communication channels that you, of course, information that are used to help clinicians to make decisions. that allows them to make better decisions. So it can be a better diagnosis, it can be a better care plan, it can be a more suitable medication, so that or a more suitable diet. Yeah, so just in general, better decisions based on information and knowledge, not just data. And how is that implemented in real systems? The channels for clinical decision support are to show alerts to the clinician, to show reminders, to show recommendations, to send them notifications. So all those are channels for clinical decision support. Yeah, but those channels, those communication means for better clinical decisions are based on systems and processes. Yeah, that allows to show or send the clinician some kind of information or knowledge that they can use for better decisions, to take better decisions. And this can be online or offline. So you can have different kinds of or different ways of accessing the alerts, recommendations, reminders, notifications. So when you're online or is synchronous, is where the doctor or the clinician is using the system, and they're seeing, or the system is displaying alerts in real time. So the system is checking some rules. We will talk about rules in a minute, but is online, is synchronous with the activity of the clinician in the system. And it has all the context information. They have the current patient, also what what the clinician is doing right now. If the clinician is filling medication prescription for the patient, that context can be used to check a rule in real time. So that is online rules or online clinical decision support. And one example is to check if the drugs on that medication are on the list of drugs or medications that the patient is allergic to them. So that is one kind of rule that can be checked in real time, is medication interactions between patient conditions, allergies, and also other medications that the patient is currently taking. But offline rules can be, let's say, if tomorrow I have a visit scheduled with my patients, and I have a system that checks a set of rules for them, for those patients, considering their clinical data. And based on that data, I can send like a notification, and it can be an email to the clinician to say, hey, this patient, currently we detected that some condition or some kind of rule checked, so you need to take a look at this. Yeah, so it's just like a notification and an alert, but this offline is something that is not when the clinician is using the system. That also can be something that is checked before the clinician is using the system, but it can be shown when the clinician is using the system. If a rule checks for a patient that I as a clinician will see tomorrow in an encounter, I can show on that encounter a reminder, an alert, a recommendation, yeah, but based on the rules that were running yesterday for the patients that I will see today. So it's not that the rules run in real time, but the alert is is appearing when the clinician is using the system. So that is like a case in the middle of full online and full offline. Yeah, so just to understand what CDS, this clinical decision support, is, and how it is implemented in a real system. And another classification we can have for clinical decision support is if the rules are checked for a patient, an individual patient, or if the rules are checked for a population. So all the examples that I was giving are just for one patient, but I can run a set of rules for a population to, let's say I want to evaluate if the patients of my clinic between 30 and 45 are in general in a range, in a healthy range of blood pressure or body mass index. Yeah, so I can check a population. I can see if my population is obese or has high blood pressure, but as a population, not just considering individual patients. So what I will do is aggregate data from many patients, from many EHRs on one rule, do some calculations, and maybe do some charts. I can chart that information, show a nice graph with that information, and tell my doctors to maybe focus on one aspect of my, the health of their population. So if in general people is more obese, between a range of age, they can if they have a patient in that range of age, they can focus on maybe obesity or high blood pressure, or hypertension, etc. So they can focus on trying to ask different questions or check the blood pressure more frequently on that population, etc. So it's information and knowledge that gives the clinician context to make better decisions and to take actions, and that those actions can improve the quality of care a lot. So that is the main thing about this, is that the focus is to increase the quality of care and improve the outcomes, improve really the health of my patients. Yeah. So these tools are just technical tools that can help, but the clinician has the last word on this. This is not a panacea. This is not a holy grail of anything. Technology can't change healthcare. Just clinicians can change healthcare. This is just an addition. It's a tool to help them. Yeah, but it's not that this will change the world. As some technology providers said, some mobile applications will change healthcare, or social media will change healthcare. That is not true. That is just marketing BS. So talking about something that is real and something that can make a really big impact. So for this to work, we need clinical data, because the rules are checked based on clinical data. So we need clinical information systems. We need EHRs, EMRs, etc. We need a way to access them. We need a way that we access all the information, obviously in a secure way, but without any blockers, and we need to access information from many systems. So we need some kind of standard. We need some kind, we need interoperability, really. And that is where the EHRServer can help. Yeah. So basically, we are going to use, I will try to do a small demo also. If we go to the EHRServer page, you will have some information here. We are going to use the one of our staging servers as a testing platform. Yeah. Then on the Learn section, you will find some guides here, so you can check them later. But I will do some videos about these specific guides also. And here below, you can find the use case map. Basically, these are all the or most of the applications of the EHRServer and the CloudEHRServer service. And we are going to focus on this area, the clinical decision support. So this is basically a very small guide about clinical decision support and how the EHRServer can help on this area. And I wrote a small program that checks some rules using data that is in the EHRServer. Yeah, I will show that in a minute. Here we can find the code. I will go there. I will open that window. But basically, here is the description of what we will do on this presentation. You can come here and read it later, so no problem there. Before starting, because I mentioned before doing the demo and specifying all the use cases and going technical, we will go very technical with this, and we will show some code. So you will see all the guts of how this is done step by step. I mentioned rules, but I didn't define what rules are. In our context, rules are a set of conditions that should be fulfilled. And if that set of conditions is fulfilled or is evaluated to true, let's say the truth value, a set of actions will be executed. And that is the key of CDS, and that is the key of what I said about sending alerts, reminders, recommendations, and notifications. Those are the channels of clinical decision support. And those are triggered by these actions. So we have conditions that should be fulfilled when they are evaluated. If those are fulfilled, a set of actions is executed, and those actions will trigger alerts, will trigger reminders, recommendations, and notifications. So how is a condition fulfilled? We need clinical information, and we have two kinds of clinical information. We have context information, and that can be clinical, but also demographic and administrative information. So the context information is like the patient ID or the EHR ID, the current date, if the clinician is using the system, and the rule is an online rule, a real-time rule. We can have information about what the clinician is doing in the system at this moment. That is context information. Let's say if the clinician is prescribing a medication, we know that the current event is a medication prescription, let's say, the current context, and we can have information about the specific medications that are being prescribed by that clinician. Also the clinician ID, the clinician, the medical specialty, if he or she is a doctor, a medical doctor, we have the specialty. That set of information is context information that is used to evaluate the conditions, the rule conditions. And also we have the historical data from the EHR. And that information is what we will take from the EHRServer. Because in the EHRServer, we have all the historical information from the patient, the EHR really of the patient, with all the data and clinical documents. So using the logic of those conditions and the context data and historical data, clinical data, we will evaluate the rules. Just execute those conditions, setting the values from my context data and historical clinical data, and check if the rule is fulfilled or not with that data. Yeah. So basically, that is the complete definition of CDS rules and how this all connects. I don't have any diagrams here. I didn't prepare a presentation. Maybe later I can prepare a presentation with all these elements, but I'm just defining stuff here. So what, step by step, what do we need to do to design or to implement CDS or a CDS, clinical decision support platform or processes using the EHRServer? Yeah. What we need to do first is to design our rules. Okay? So we need to have an idea of what we want to accomplish, what we want to do. So what I will do is just think of a small rule that is very basic. The rule will be, I want to check if a patient, so it's for an individual patient, not for a population, has at least 5 measurements of blood pressure that is high in the last 12 months, in the last year. Yeah. So my idea is to check if the patient has more than 5 records of high blood pressure in the last year. That is my rule. That is the logic of my rule. So once that I have the rule, so you can put there any logic that you want. So it's your design. So for me, for this example, this small example will be just that. Check if the patient has more than 5 reads of high blood pressure in the last 12 months. Yeah. So I have that data on the EHRServer. I know that I have the blood pressure reads for my patients on the EHRServer. So I need some query, some type of access to that data, to that specific data. So I will create a query, and to create a query, I will go to the staging server. You can create I will put this in English. So you can create an account here. It's a testing server. So this server is slow, but this is working. It has almost the last version of the EHRServer. You just create an account here, and you can use it the same way as I'm using it. You will be asked for a username. You will receive an email to reset your password. So you establish your password. We don't set passwords for you. And you will be given an organization number that you should use for accessing the server. So basically, when you create a user, you also create an organization that will be assigned or you will manage as an organization manager. Yeah. So you need the three data points to access the server: username, password, and organization number. So I will just sign in. I will go to the queries section here. I won't do a full demo of the EHRServer right now because you have the video, so you can just come here and watch the full demo of the EHRServer. I will just go straight to the point for this presentation. So I have already created a query to check high blood pressure. Yeah, but I can show you how this is created. So I will create a new query, and queries, this is the interesting thing, are created using the user interface. So we have a query builder here. You don't need to write SQL to access your data. You don't need to change the source code of the application to access your data in different ways. Yeah, you just need to come here and create a query in the way I am doing it. So what I'm doing is assign a name, select the type of query that I want. I want composition query that is a query that will return clinical documents, not data points. If I want data points, I will select the data value here. these are names of the OpenEHR specification. So I will come here where it says concept. I want blood pressure, and blood pressure has a set of data points. So I want high blood pressure. So I will select systolic and establish a condition. So systolic, I want the systolic to be greater than 140 millimeters of mercury. These units come from the concept definition of blood pressure that is defined using the OpenEHR standard. And I will add this criteria to the query. And this is the definition of high blood pressure. If the systolic is greater than 140, or the diastolic is greater than 90 millimeters of mercury. And it's an OR, so it's one of those two conditions. So I will select OR here, yeah, and that's it. This is a query that will return all the documents for a patient. The specific patient is given as a parameter when the query is executed. So here we are defining the query, and the conditions are here. Yeah, this is blood pressure. This identifies systolic greater than 140 blood pressure. This identifies diastolic greater than 90. Then if I want to test it, I can test it online with real data. And here I can select a patient. So I can select a patient. I can select if I want the data from those clinical documents or not, and execute the query. And this query is returned in XML. I can choose to return JSON, and I will see JSON. And this is the same information that you will see if you execute the query using the REST API. It's the same information. And these are, as you can see, not clinical documents, are references to the clinical documents that contain any record of high blood pressure. Yeah, but I didn't did any type of filter to check my other condition. I want to check if the patient has records of high blood pressure in the last 12 months. So what I can do is select from, and I can establish a date here. So I can select 1 year before, and I can execute the query. So I have filters, and these filters are passed dynamically from the REST API when you are executing the query. So that's it. It's basically it. And you can see here that they have 1, 2, 3, 4, 5, 6 records of high blood pressure that contain high blood pressure. And this is the identifier of a clinical document that contains high blood pressure. If I select here, retrieve data, let's say if this works, it will take longer to execute because clinical documents are longer. Here I have all the full clinical document that complies with the OpenEHR standard. And if I look for high blood pressure or for the blood pressure records on this document, here I have a section for vital signs. Here I have the entry for blood pressure, and I will look for the systolic and diastolic notes. I have all the document, all the information here. I have blood pressure systolic here, and I have here a value that is insane. This is just fake data, but you can see that this is high, and this is also high. So I have the systolic and diastolic. That is why this record matches my query. Yeah, so you have both ways. You can query all the document, the full document, or just query the instances. Because we want to know if there are 5 records with high blood pressure in the last 12 months, we don't need the internal information of each document. We just need to count the documents. So I will not select to retrieve the data. So it will be quicker to query. Yeah. And if I click create, I will create that query. Because I already created this query, I will just leave this query here and go back to my original query. That is exactly the same. If you see the conditions here is systolic blood pressure greater than 140 and diastolic greater than 90. Yeah. And if I click edit, I will go to the same query builder screen that I was, and I can execute this query and I will get the same results as I show you. So this is basically what you need to create first when after you decide what your rule will do. So the rule will count if there are at least 5 records with high blood pressure in the last 12 months. So I created a query to get the records that have high blood pressure in them. Yeah. Then to access the API, because it's secured from the rule that is executed, I need an API key. So what you need to do after you design your query, you need to go to your organization. My organization here is CaboLabs. Yeah. And you go down here to API keys. Yeah. So you can generate a new API key. You put here the name of the API. You can put just clinical decision support, rules, API, blah, 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 and create. And the EHRServer will generate something like this for you. And this you need to copy and paste in your code. Yeah, you need to be sure this is private because this is used to access the API. It's like a password. So I am showing this to you because this is a testing system. Yeah, this doesn't have real clinical information or real patients or anything. This is just for testing. This is our testing server. And I will use this API key. Yeah, the one that is named EHRServer client Groovy. Yeah. So basically, we have a mean to access the EHRServer API using the API key, of course, and we have a query that we can execute using the REST API. So basically, we will use those things. Yeah. And after this, you need to actually program your rule. You need to code your rule. Yeah, you can use some kind of rule builder. You can use some kind of framework, or you can just write some code yourself. So this is not difficult to do. And I will show you how I wrote this code. So basically, if you go to, you will grab this code. You can execute. It works. From here, you go to learn. Then you click on the chart, the clinical decision support, and here you have a link to clinical decision support example that will lead you to this page. This is one of my repositories on GitHub. Basically, it's one of the clients I wrote for the EHRServer. It's a wrapper to use the API. Yeah, so this is a wrapper for the Groovy programming language. It's a dynamic programming language for the Java virtual machine. So it's like Java, but you can write less code with and do the same thing. Yeah, and inside this project you have an example of clinical decision support, and I will go from top down. Yeah, so I have this suite class here. I use this suite class to connect to the server and try to evaluate the rule. Yeah, this is for doing some setup. Yeah. So I create a rule. I will show you the rule code in a minute. So I create the rule. This is the rule that checks if a patient has more than 5 records of high blood pressure in the last 12 months. Yeah. So basically, all the logic is there. What I want to do is to evaluate this rule using some context information. What is the context information that I will give to this rule? Is the EHR ID for my patient. The EHRServer doesn't use real patient IDs or real patient data. The demographic data, the identity data is not on the EHRServer, so it's anonymous, really. And the identifiers for the EHRs are all auto-generated. Yeah, so you can't you won't know any personal information from this ID. Yeah, but I know that I have a patient with an EHR with this ID in the EHRServer. Yeah. So this is a parameter for evaluating the rule. And if the rule checks, if the rule is fulfilled with the data from this EHR, I will execute a set of actions. So the actions can, as I said, throw an alert, send a reminder, show a recommendation, or send a notification. That can be online or offline. And here, what I did is just I wrote a very small action that is just printing the results of the rule in the console. It's not more than that. But you can do whatever you want. You can send an email, send a message in Twitter, or send a message in WhatsApp to the WhatsApp of account of the clinician, or send if your hospital has an internal communication system that use some kind of chat system like Slack or River, that is like a free version of Slack. You can send a notification there, or you can just return a value that will be taken by a system, or you can invoke a remote API or a service that is in charge to throw or to show the alert, the recommendation, or the reminder in a system to a real doctor. It can be real time or offline. Yeah, you can do whatever you want. So this is very basic, and I didn't did any of that because that will be too system dependent. So I just show some stuff in the console, and I just evaluate the rule with the parameters with my EHR and my actions. Yeah, so this is just it. It's 1, 2, 3, 4 lines of code. This is just to set up the rule. See? Yeah, very basic. This comment is just to show the output from this rule when the rule checks. Yeah, when the rule is fulfilled. For the action, I created a small interface. So basically, with this, you can implement your own actions. Just you just implement this interface. Yeah, very basic. And I have one action that implements this interface. And this action, what it does is just printing the parameters. Yeah, so very, very, very basic. It does nothing. Here you can put your own code, and you can send emails, invoke remote APIs, web services, send posts to Twitter, whatever you want. Yeah, you just change that code. And the rule is the core of all of this. Is where the conditions lie. So this is the knowledge. This is the clinical knowledge. What I do here is I create a new instance of the EHRServer client. Remember that this project, this CaboLabs EHRServer Groovy, is a client for the EHRServer. So basically, what I'm doing here is create an instance of that client, so that I will use that as a proxy, as an interface of the EHRServer API. I provide the URL, and as you can see, I am using the same server that I show you here. Is the EHRServer CaboLabs 2. EHRServer CaboLabs 2. I'm using the same server. The connection is secured. And here is the evaluate method. So here, what I do is receive the parameters. This is the context, and receive the actions that I will execute if the rule is fulfilled. The first thing I do is to assign the query UID. From where you get this query UID, you go to the query that you created here in the EHRServer. You just go to the show page, and you can grab this UID from here, and you can see 7D125 blah blah blah, 7D125 blah blah blah. So it's the same ID. I am executing that specific query. Yeah. The second thing is I need to get the API, the API key. So you can see here is EYJH blah blah blah, and I API key EYJH blah blah blah. So I have the query UID, the API key. I set the API key to the client. This is the EHRServer client. Yeah, I set the API key, so I can now access the API, and I can execute all the methods in the API using that specific key. But I want to execute the query. So I use the client to execute the query. I pass the query UID. So this is basically, I want to execute this query for this EHR, and the EHR is taken from the rule context parameters. Yeah. And I set here a from date. So what I'm doing here is just add a filter for the query, and the query will return just the results for this query, that is get all the records with high blood pressure, and this will take the records from the last 12 months. So this is the last year. So current date minus last year, this will get a date 12 months ago. Yeah. But the new date, this is evaluated every time this rule is executed, is evaluated. So the new date is the current date, always. And the output format is JSON. I want JSON as a result. And the result will have all the records that have high blood pressure in the last 12 months for that patient. Yeah, and it will look like this. It will be a set of these results. It's the same that I show you executing the query on the EHRServer rule builder user interface. Yeah, so I want to get the results from the rest variable. Yeah, and check if the results are more than 5. So here I do this. Result size more than 5. Yeah, and this is the condition that is fulfilled. If the condition is fulfilled, what I do is I execute all the actions. This is Groovy notation. What it does is take all the items on the actions list and applies the execute method. Yeah, so it is just executing the execute method for each action in the actions list. Yeah, and here what I'm adding is to the parameters is the results of my query. So the actions have all the context, will have the EHR ID, but also the results from my queries, and that's it. Is basically mostly setup of the connection to EHRServer is 1 line of code, 2 lines, 3 lines, 4 lines, 5 lines to execute the query, and 1 line to check the condition. And why is that so simple? Because most of the logic for this rule is already checked on the query criteria. Yeah, because I have the main conditions there. The high blood pressure conditions are specified on the query. Yeah, I don't have here. I'm not checking the high blood pressure here. I'm just counting the results because I already know that the rule is returning results of high blood pressure. Yeah, so between the rule that is already smart enough to give me meaningful information, here I add more logic to check the data. Yeah, so the query has its limitations in terms of the conditions that you can establish. But if you combine the conditions of the rules and some program logic, you can do whatever you want. Yeah, and that's it. This code is mostly comments, so it's 6-7 lines of code to check something that will execute a rule and execute actions that will trigger sending alerts, sending reminders, sending recommendations or notifications to allow clinicians to take better decisions based on information and knowledge. And this is all the knowledge implemented in a query and in a rule condition. This is basically it. So you can, this is very simple. You can improve this or implement your own rules just following these simple steps. You design your rule, you establish your conditions, you generate all the queries that you need. In this case, I just need one query, but you can, if your rule is complex and uses a mix of different conditions and different information, different data, you can have 3, 4, 5 queries created, and you can call those queries, execute those queries, just adding this line, yeah, and changing the parameters here if you need to. And you will get all the data. The key thing is to get all the data that allows you to check the condition that you designed for your rule. Yeah, and you need to have an API key that is generated in 2 clicks. Yeah, so it's nothing. And implement your own actions. Yeah, if you need to integrate the results of a rule with an external system, with an API, with I don't know, another tool, you just create your specific action with logic to send information under the rules. The condition is fulfilled, and you will know that the condition is fulfilled because you received the notifications, and you can send all the context data to those systems. You can send the results of the queries to those systems because you have the results here. So the actions can take the results as parameters and do whatever you want. Yeah, so you can create reports based on rules or whatever you want. This is limitless, really. It depends on what you want to do. But the basic thing of this is you have a server, a backend that is easy to access, has all the information, and will give you all the information in a flexible way. And you can create different queries without changing the source code or without changing the database structure. You don't need to do that because the EHRServer is already generic. It will give you all the, it will store any kind of information that you define in an OpenEHR way, and it will give you access to all the information without any restrictions. Obviously, we have security rules and we have different security layers to access the data, and you need, of course, to be careful when you create the API keys to not publish those keys. Of course, that you see here is openly available, and I have an API key here. I have this API key here because we don't have real information here. So in production, this is secured. And if you detect, if you commit, if you have an error and you accidentally publish this, you can just remove the API key, and the API key won't work anymore. Yeah, and you have you will have access to all the logs to detect if a key was compromised. Yeah, but that is not the focus of this presentation. Yeah, and what to finish this presentation, this is very clear, I think. If you have any questions, you can send me an email later. You have all my data here, I think. You can send me an email to pablopasos@cabolabs.com, pablo.pasos@cabolabs.com, or you can come here and use the contact form from the CaboLabs website, or use the contact form from the CloudEHR server website also. And just a summary, and something that I mentioned, if you want to create a more real-time rule, you just need to pass information that is about the current context, like the as I mentioned this like 3 times already, but if you want to here check if the patient is allergic to a medication that is being prescribed by the doctor that is currently using the system and creating the prescription, what you will receive as context information here is the EHRD. You will receive the medication that is prescribed to the patient, yeah, or you can receive the drugs, and what you will do is to create a query. Yeah, this query will be like give me all the allergies for this patient that are related to medication, something like that. Yeah, or you can just get all the allergies and check if the allergies are of type, medication. You need to do some logic. Also, because we are talking about medications, we are talking about drugs, and sometimes you get the medication ID, but you don't have the components, the drug components on the prescription screen or in the EHR. You might need to query another system that has, maybe the pharmacy system that has the components of each individual medication, yeah, and using that also to complement your rule logic. So it's more complex, but the basic information can be stored in the EHRServer and can be accessed in 4 lines of code. It's like nothing. Knowing the process, you can really create any type of rule. Yeah, and as I said, this is a simple example, but there are rules that can be built using frameworks or tools that are focused on doing that. But with this sample code, you can create some simple rules with within maybe 10 minutes. You just need to follow the process I described before. Yeah. So if you have any questions, just let me know. What I will do, this video will be available in YouTube. Will be recorded there. I will send that video in Twitter, in the social networks, Facebook, etc. So I will share this video later so anyone can see it there. And this is the first video of a series of videos describing different use cases for the EHRServer. I think the second after the clinical decision support will be monitoring and wearable devices, because this is fun. So here is the guide, the basic guide. And I will give you I will try to give you some working examples, some code. And I did this, but I have a working example for the code I show you. This is the terminal. So I am here in the this is the working code. So I'm here in the I have a copy of the CaboLabs EHRServer Groovy project, and if you come here, you can see some files. If you are on Windows, you can just run the CDS, the rule that I show you using the .bat file, or in Linux that I'm working right now on Linux, you can just run the shell script. I will run this. You need, because it's written in Groovy, you need Groovy installed, of course, to run it. So I will run this. I will run the rule. what it's doing there is connecting to the EHRServer here. It's using HTTPS, so it's secure, it's using certificates, all of that kind of stuff, security, blah, blah, blah. And then, because the rule is fulfilled, because the patient that I queried, the EHR ID that I use is of a patient that has more than 5 records of high blood pressure. So the result is the print in the console of all the data. That is the context data, the EHR UID, but also the results. As I show you, the rule adds the results of the query to the parameters and pass that to the action. And the action is just printing in the console. That is what you are looking at right now. If I create another EHR and execute the rule using that EHR ID, I will get an empty result here because it won't have any data, or at least won't have any data about high blood pressure. So the rule will not be fulfilled. But this is a code that actually works. So this was the last thing that I didn't show you. And that's it. If you have any questions, just let me know. Next time I will schedule this. I will try to do one of these presentations a week, or each other week. Next one will be this one, I think, the use case for monitoring and wearable devices. But basically, it's always the same thing, but different use cases. To use the CloudEHRServer as a backend for systems that do something useful for end users. As you know, or if you don't know, the EHRServer is a backend system. So the user interface that you saw is for administration. This user interface is not for end users, it's not for clinicians, it's not for patients, it's for administrators or organization managers. We have different roles. So you can see all the data on the system, you can audit, you can create queries, etc. And you can add more structures of clinical information that you want to store in the EHRServer. That is called templates, are structures of clinical documents, really. You can add more clinical documents to EHRServer just by adding definitions. These definitions come from the OpenEHR standard, the OpenEHR specification. So basically, the possibilities are limitless because you can add more structures of data and you can add all the queries that you want, that you need. Yeah. So you can just add definitions of clinical documents, then you add data for those clinical documents, and then you create the queries, and that's it. And the queries are executed from the API. So this is the main use case, to be a backend for front-end systems, yeah, that are used by clinicians, by nurses, technicians, or by patients. Yeah, if you want to create a personal health record or a patient portal, you can create the front end, and you can use the CloudEHRServer to store the data and retrieve the data in different ways that you need to show or display the information, visualize the information, or to execute, like I show you, some rules to show alerts, recommendations, reminders, notifications, etc. So that's it for now. I hope this wasn't too heavy, and I hope you understand the basics of clinical decision support. That's it. Just drop me an email if you have any comments, questions. I'm happy to answer all your emails personally. And one last thing is that the CloudEHRServer is right now on beta. So it's not open for registration. You can't use it right now, like buying a plan, like any software as a service tool, and pay by month, etc. Right now, that is not enabled yet because we are trying to deliver a high quality tool, and we are in the middle of improving a lot of things to have that high quality product and service for you ready. Soon, it will be this year. But right now, what we are looking for, because we also don't have any type of funding, we are looking for beta partners that can help us on funding the project, but also that are interested on using it in the future, in future projects. So what we are asking for is to sign as beta partners for individuals or small companies or big companies, whatever, that want to use this service, use the product to make it better, and also to help us grow, but also grow with us. And basically, we are this participation of the Better Partner Program is you pay just a small fee, and you can access all the backend without any restrictions of use in a production server. It's not the staging server that I show you. It's the production server. So it's a bigger server. It's faster. It's more secure, and you will get also as a counterpart. You will get training. You will get premium support. You will get direct access to me. You can call me. We have hangouts with the current beta partners that help us and help us a lot. And the fee is not too much, but each individual contribution help us to support the infrastructure. We are paying actually for the infrastructure. It's working really well. It's not so expensive, but we think we can improve the infrastructure, and we can scale the infrastructure if we have the support. This is just to give an initial base for the project to make it scalable, but also sustainable in the first 2 years of the product. This was launched this year in January. That when you launch a new product or service, it takes some time to bring it to market and to have real customers using it. And it takes, in healthcare, it takes maybe 1 year or 2 years. And we are trying to, because we are paying for the infrastructure, we are trying to make it sustainable for these first 2 years. And the beta partner program is the way that we find that will have high level of interest. People that really want to help the project can join and can contribute. So it's a high quality type of contribution. But also we are getting back something, so it's just not the contribution. We are also sharing knowledge. We are doing, as I said, these talks are open, but we are doing premium support to them. We are helping them. We are sharing knowledge with them. We are teaching the beta partners how to use the EHRServer, and also how helping them understand the OpenEHR standards and specifications. I mentioned that a lot, but I didn't share what I was talking about. If you don't know OpenEHR, just come here and read the basic tutorials here, the guides, what is OpenEHR, who is using it. There's a lot of interest in Europe right now. And last year, India adopted OpenEHR as a national standard from the Ministry of Health. So that is great news for the OpenEHR standard community and for the OpenEHR Foundation. So great news. And also in Brazil, for just, I think it was 5 years ago, something like that. Also, they adopted OpenEHR as a national standard. So it is getting slow adoption, but steady. I think it will get a lot of adoption in the next 5 years. And there are a lot of projects right now in Europe, in Norway, in UK, Netherlands, etc. So check who is using OpenEHR. You will see a lot of movement there, and we are trying also to get attention, to the EHR, to the CloudEHRServer, because we think we solve a specific problem in the EHR, but also in the OpenEHR world, by trying to give a very generic, very flexible backend for clinical applications or clinical systems, and I think it will get traction and will be adopted by many companies soon. But as I said, we are trying to improve the system, the service, the product to reach that stage of stability, and it's stable. It was stable for the last 3 versions, but I think that level of quality that is needed for a production-ready tool is production-ready right now, but I think it can be improved in some specific areas. But we need your help. We need your help to improve the system and to improve the service. Yes, and next time I will see you and I will talk about another topic in the use case map. Yes, and this is all available here, so you can check it later. Yeah. So, but right now, just thanks for watching. You can subscribe to the CaboLabs channel in YouTube, and as I said, just comment, leave me your questions in YouTube, Twitter, send me an email, etc. I will answer you as soon as I can. Yeah. Thank you for watching. Bye bye.